Vipin Bhardwaj. He is a water supply expert who has more than 23 years of experience in engineering consultancy of wastewater and water supply projects. He has a bachelor's degree in engineering from University of Pune with master's degree in civil and environmental engineering from West Virginia University, USA. He is currently working as a vice president of operations with Mars Planning Engineering Services based at Ranchi and has worked in several leading consulting engineering firms in India such as STC, Tata Consultancy Engineering, NJS. He has worked in extended funded projects such as ADB, Japan Bank International Cooperation, JICA, and in USA. His experience has been multidisciplinary. And he is from Mars Planning Engineering Services. And the topic is Sustainable Rural Pipe Drinking Water Supply for major region of Santhal Pargana area in the state of Jharkhand. So this is regarding the supply from river Ganges to this area. This is a big project of DWSD. So please welcome Sri Vipin Bhardwaj on the stage with a big hand. Where is he?
Thank you, sir, for the introduction. Good afternoon, everybody. This is a presentation on sustainable rural pipe drinking water supply for major region of Santhal Pargana area in the state of Jharkhand using river Ganga as a source. The project background: Godda district is one of the most water scarce region in Jharkhand, and the present population is dependent on groundwater and wells. Groundwater resources in Godda and adjoining areas are depleting very fast, and the status of the groundwater is overexploited. So also the entire district drains off into Ganga basin and into river Ganga which flows on the northern side about 25 kilometers through the rivers Chir and Gumani. At present, also there is no major reservoirs or dams within the district except Sundar Dam, which is used for Godda urban as a water source. Creating of new dams or reservoirs was a very time-consuming and tedious process with lots of potential social and environmental restrictions. Hence, we have created a mega district-level scheme which was cost-effective compared to each single village schemes or multi-village schemes. The objective of the project is to cover 100%, is to provide 100% sustainable drinking water pipes for water supply within 9 blocks of Godda. We will be covering the whole Godda district, 3 blocks of Sahibganj, and 2 blocks of Dumka using river Ganga as a source at Rajmahal. The present water supply is intermittent and unreliable, and it is using groundwater, and most of the households are using dug wells, hand pumps, which is not reliable. So this project was formulated to address these gaps in the water infrastructure in a holistic and integrated manner. And the main objective of the Drinking Water and Sanitation Division is to improve the water supply efficiency and have a positive impact on the public health and environment. This slide depicts the fall in groundwater. As you can see, for Godda, the water depth is 17.5 meters, and during the last 2009 to 10, almost 5 meters of difference in water levels was observed for the groundwater. Also for Godda, there is a fluoride fluoride is present beyond 1.5 milligram per liter for Godda district, which makes the groundwater unsuitable for drinking purpose. So this is the selection matrix. Groundwater reliability was highly unreliable, and there is no perennial rivers. And also the source, although having wells and individual wells and dug wells would have been cheapest, but it's not a viable option. And also the source of cost of source development for extraction of around 231 MLD through reservoir and dam would have been very costly. So we have, and there are other social and technical issues for the groundwater and creating new reservoirs. Hence, Ganga was a viable source and a sustainable source for water supply, which we have selected as a source for this mega water supply scheme. This is an overall snapshot. We are providing 65 LPCD to the consumer, and we are covering in the base year 2020 around 17.96 lakhs, and the ultimate designed capacity is for 23.71 lakhs. The water supply rate is 65 LPCD, which covers 55 LPCD at the consumer end, along with 15% losses. We are covering 14 blocks and totaling of 271 panchayats. We are covering 3,264 villages and about 3.32 lakh of households. This covers a state, almost 6% of the state population, and an area of around 5% of the state, which is around 5,000 square kilometers. Next. This is the illustration of the scheme. This is the river Ganga and Rajmahal, we are going to pump water from two floating intakes, floating jetties from Rajmahal, and then we are having 6 major reservoirs. The red color ones are the rising main, where we'll be using pumping to Taljhari 1, Taljhari 2, 2 reservoirs, and then the rest of the green colored ones are the where you can the water flows by gravity. So this will flow all the way to Meherma, and from there there's another intermittent pumping, and then ultimately the water is coming to Godla district in Mahagama reservoir. And then after that it is all pumping till the downstream sources, till Ramgarh and Sarayahat. Next. The scope of work, it covers construction of floating jetty at Rajmahal. The raw water transmission main length is 87 kilometers. The diameter, pipe diameter are from 1100 to 1800 mm. There are 13 WTPs provided at different locations. There are 6 main GLSRs. There is 1 ESR at each panchayat, a total of 271 elevated service reservoirs. The clear water rising main length is around 1200 kilometers. The entire distribution network for this project is around 5,500 kilometers. There are 14 number electrical substations, and we are going to provide around 3.32 lakh house connections. Next. This is the topography of the area. The topography is highly challenging, There is undulations at several places, and that is why from Rajmahal, we had to pump water to the Rajmahal hill, which is at an elevation of 190 meters. And from there, it flows by gravity downstream, and there's intermittent hilly terrain, as you can see. Because of that, we have intermittent pumping at several locations, and that is why we had intermittent pumping. Next. This is a hydrology of the Godda district, and the rocky strata. See, the blue, the yield of wells in the blue color is around 25 cubic meter per hour. In the blue colored region is around 20 near Ganga. And further down in the southernmost part, it is less than that. Just a minute, Mike. So, as you can see here, the yield is around 50 to 150 cubic meter per hour in the orange colored region, and in the southern part till Puriat at the downstream end, it is below 20 cubic meter per hour. So groundwater was not a sustainable source. This is the entire pictorial representation of all the schemes. There are, this work has been awarded, and there are around 8 major contracting firms that are mobilized and under different stages of execution. Next. This is the habitation summary. The total number of villages in the habitation is 2,390. Next. We use the population projection using CPHO methods, and for 30-year horizon, using 2020 as the base year, 17,96,000 was the population, and in the 30-year horizon, the population was 23,71,500. Next. The water demand calculation, as you can see, for the ultimate year, 30-year horizon, it is around 209.15 MLD, million liters per day. Next. So for the project, these are the different activities performed. During pre-construction stage, there was DPR preparation, then technical sanctions had to be taken, then bid process was followed. Then we had assisted in award of work to agencies and liaising with other departments for paperwork, and put necessary quality assurance, quality control systems in place before the start of execution. During construction, we are ensuring that the work is carrying out as per technical specification and tender drawings, and we are ensuring water quality, work quality is as per the specifications and drawings. We are carrying out material inspection as per QAP and standard QAPs. Then we are monitoring the progress of the project in time, cost, and quality, assisting with the measurement of work and verification, and scrutiny of the bills and regular reporting of the progress. Also assisting in audits, VIP visits, legal issues, any conflict resolution, and then post-construction, we will ensure that the delivery is as per the plans, as in timing, and also in giving water supply connections to consumers. Then pre-commissioning, commissioning, and tests, making periodic site visits to ensure that work agreed is completed by the contractor. And at the end of the defects correction period, and when all outstanding works completed, all repairs are carried out satisfactorily, and to issue the defects correction certificate in accordance with the contract. Next. This is an illustration of all the 6 major, the transmission main, 87 kilometers, and different capacities from the intake till the 87 kilometers transmission main, till the Sundar Dam. Next. The existing coverage within Godda district is also, FHTC covered is around only 20%. So the total left is around 2,26,518, which we will cover in our project. These are the details of the 13 WTPs of varying capacities. The total capacity is totaling to 155 MLD. Next. These are the summary of all the rising, raw water rising main and head losses. As you can see, the major pumping is at the first 2 locations, at the intake point and at Taljari. Next. This is the floating type of 2 floating jetties that we will be having at the intake location. Here, because this river Ganga is also used as a navigation for inland waterworks, permanent intake was not feasible at this location, and we could not obtain for permanent intake any permissions for that. That is why this floating type of jetty was selected. NOC from inland waterways was taken for this, Also NOC from Central Water Commission and land availability. We had tried several locations. 4 locations we have tried, out of which we could obtain final approval for only the 4th option from the Inland Waterworks Department. This is the location of the intake well and Ganga Raj Mahal Hill. Next. So from the 2 intake jetties, we are going to have a 750 mm RCC bridge, and then there will be a permanent base for the electrical transformer and the pumping station. This is the NOC that we obtained from the Inland Waterworks Authority of India. Okay, this is showing the earlier one of the plans was to have it near the Adani port, and several options were studied for locating the intake. And finally, the green one shows the location where it is finally approved. Okay. This is the drawings for the floating jetty. Next. The bridge. These are the different villages where this transmission, 87 kilometer transmission will pass through. This is the details of the clear water mains, around 1200 kilometers for each block. These are the major all capacities of the pumping stations and the pumps. So 271 OHRs will be located at each panchayat, 1 at each panchayat. This is the all block-wise detail of the distribution network. Around 5,500 kilometers of network is designed and planned to be laid. This system will be SCADA controlled for the major part, for the transmission main part. All the 6 GLRs and transmission main will have SCADA controlled monitoring. Thank you.
What is time frame you have fixed for this construction total project? Have you fixed some time frame for it? And what is your progress rate?
30 months is the time frame. The work was awarded in March of 2022, and then it will be till 2025.
And you are adhering to your progress, like percentage-wise, as per your target, you are achieving it?
Around 35 to 40% is the progress. Its work is awarded and its execution is being carried out at site.
Thank you.
Thank you, sir.
So this was a presentation by Vipin Bhardwaj from Mars Planning. This was a wonderful presentation on water supply from river Ganga. So I would request again the chairman, Rajiv Lochan sir, to present him with bouquet, shawl and memento. Thank you so much. Now, as we had told in the inaugural session, that today we have with us a bridge and metro expert from Mumbai. and his topic of presentation is bridge bearings, manufacturing, testing, installation issues. And he is none other than Sri Anand Bandhu. Please welcome him with a big hand on the stage. Please.